Hey, I know that you guys are stuck at home right now. We're not in school. We're doing our NTI days, and there was some confusion about this chi-squared business. So I'm going to try to clear the air for you on this and made this video for you just so hopefully you can get a better understanding of what we're talking about and what the expectations are of you in AP Biology for this subject. This is something that could potentially be on your exam, so I think it's really important that you know about it and you understand how to work these problems out and solve for them. So what is chi-squared? The chi-squared test is simply us doing a test to see if results are legitimate or not. All right, let me give you an example. So let's say that I came into class one day and I said, hey guys, last night I was flipping a coin and I flipped it 20 times and all 20 times I got tails. You'd be like, Mr. Farmer, there's no way. There's no chance that you did that. You're lying to me. And you'd be right? It's not possible for us to do that. And so chi-squared tests look at probability and look at the outcome that we get, and it says, is this legitimate or not? Is this something that could actually happen or not? And that's chi-squared for you. We use it all the time whenever we're looking at genetics. So a lot of these problems will be genetics, like this first one. We can also look at it in anything that occurs chance, playing rock, paper, scissors, choosing certain items, rolling the dice. Anytime that there is a predicted and expressed outcome probability-wise, we can do this to see if the results are legitimate or not. So is the probability true? Is this something that could actually happen? Or is there some sort of outside factor that's influencing this some way, shape, or form? Okay. The way that we solve this, we'll always have a problem. We're going to go and we're going to use a chi-squared value table to fill these in as we go through. We're going to need our critical numbers and look at the degrees of freedom here. And then we're going to compare those numbers at the end. Now, it's really important to realize if the critical number at the end is greater than the chi-squared value, then we're going to accept the null, which basically means, oh, this could actually happen. This is legit. If the chi-squared value that we get at the end is greater than the critical number that we get, then we know that we need to reject this null hypothesis. This is not true. Something else is influencing this some way, shape, or form. Okay? So let's go ahead, let's get started. I'm going to show you how to do this step by step. Hopefully it'll help you out so that you can do this on your own. In peas, yellow seeds are dominant to green seeds. A heterozygous plant is crossed with a homozygous recessive plant to produce the following offspring. Yellow, 52, green, 48. All right? So we can go ahead and fill this out on our chi-squared table. Our observed values are 52 for yellow and 48 for green. So observed is 52 for yellow and 48 for green. Now, this chi-squared table is really nice. As we go through, all we have to do is add these to get our total. 52, 48 gives us 100, okay? Now, what were we expecting? What was the expected outcome of this cross? Really simple to figure this out. We just look at probability, and to figure this out, we're going to use our Punnett square. All right, so let's just do a simple Punnett square here. We know that heterozygous, big T, little t, is going to be a yellow. And we also know that a homozygous recessive, little t, is going to be a green. All right, let's fill this in. Punnett square, big T, little t, little t, little t, big T, little t, big T, little t, little t, little t, little t, little t. Okay. So it looks like I've got a 2-to-2 ratio here, which basically is telling me that there's a 50% chance that it could be yellow and a 50% chance that it could be green. So I need to fill that in on my table as well. So we'll go over here to the expected. 50 and 50. So if I did this 100 times, I would expect there to be 50 yellow and 50 green. Okay. Now all I need to do is just continue to do what the chi-squared table tells me to do. Observe minus expected. So 52 minus 50 is going to be 2. 48 minus 50 is negative 2. And then total, that's going to add up to 0. This guy should always be 0 whenever we're doing this. Next, we're going to square these. So the observed minus expected, which is what we found here, just simply square it. So 2 squared is 4. Negative 2 squared is positive 4. You don't have to fill this guy out here. It's kind of pointless. You can if you want. It'd be 8, but it doesn't really matter. Now, for this last part, you probably need a calculator. Got mine right here. You can use the one on your phone if you don't have one at home. But we're going to simply just solve again for what it says here. Observed minus expected squared, which is 4. Divided by the expected, which is 50. So 4 divided by 50, 4 divided by 50 is going to give us 0.08. And then the other one is the same thing, right? So 0.08. Add those together. My chi-squared value here is going to be 0.16. That's my chi-squared value. So x squared, chi-squared is going to be 0.16. Now, here's a big part of this too. I've got to figure out what in the world is this critical value, right? So a critical value is going to be these values down here, and these are basically these are just what we call confidence intervals. So we're saying, okay, I am 95% confident that these results are true, or I am 1% confident that, or 99% confident that these results are going to be true. So it's a confidence interval. It's us saying I'm 95% sure, or I'm 99% sure. For AP and for me, we're always going to use 0.05. We always want to be at least 95% sure. So always use the 0.05 row unless told otherwise. Okay? So let's go ahead and let's do that. We know that we're in the 0.05 row because we're 95% confident. But where do I go? 1, 2, 3, 4, 5, 6. I don't really know. Where am I going with this? Well, degrees of freedom is simple. All I need to do is calculate the number of options that I have in my trait and then minus it by 1. So if you look, I only really have 2 options. It's going to be yellow or it's going to be green. One or the other. All right, so I'm going to say 2 minus 1 is going to give me 1. So I know my degrees of freedom is 1. Find my 0.05, go over to the 1 here. 3.84 is going to be my critical number. Okay. So I need to look at this now and I need to make that decision. Which of these is going to be higher? Obviously 3.84 is higher, much higher, okay? So my critical number is higher than the chi-squared value. We are going to accept this null hypothesis, okay? And that makes sense, right? Let's say I told you that I had 100 pea plants. I was expecting a 50-50 ratio, 50 yellow, 50 green, and we ended up with 52 and 48. Would you look at that and be like, yeah, that's probably true? Yeah, I mean, that's pretty solid data right there, okay? So at the end of the day, what I want you to be able to do, I need you to be able to figure out that chi-squared value by using the table over here. And then I also need you to be able to figure out what my critical number is going to be by using the degrees of freedom and this scale that's going to be given to you. Again, this will be given to you on your AP cheat sheet. You will have this. You do not need to memorize all these numbers. You just simply need to use this as a tool and know how to navigate and use it. All right, round 2 here. I've got a little bit more practice for you. It's a little bit more advanced here of our chi-squared work. All right. So I've got a kind of a silly example for you, but I hope it helps you along the way. Mr. Farmer plays rock, paper, scissors with Mr. Click 300 times. Below are his selections. So Mr. Click has picked rock 75 times, he's picked paper 200 times, and he's picked scissors 25 times. We want to know, is Mr. Click being honest whenever he's doing this? Are we going to accept that null hypothesis here that he's playing fair? Or are we going to reject the null hypothesis and say he must be cheating here to try to beat Mr. Farmer, something that he desperately wants to do but has a hard time doing? All right, so we need to go ahead and we need to set up our table here. I've got it for you. You'll notice something different about the chi-squared this time. Notice how instead of 2, now there's 3 options here in the middle. We've just added 1 because now we have 3 different options here. I've also got our critical value chart up here too. Let's go ahead, let's start solving this baby. All right, so here's the observe. So we observed Mr. Click pick rock 75 times. We saw him pick paper 200 times. And then we also saw him pick scissors 25 times. We add all of those up together, we're going to get a total of 300. Now, assuming that there are even odds to pick all 3 of these, and there's 300 total, we should say that, okay, if there's 3 of them and there's 300 that he's going to pick, we're going to probably see that he's going to pick each of these on average 100 times is what we should expect, right? If the probability is even for each of these. Now, I'm looking at this and I'm seeing there's a big difference between these numbers. I'm sitting here thinking, Mr. Click's probably cheating, right? But let's go ahead, let's do the test, make sure that we're doing this right. So we expected 100 from each of these. Again, this should add up to 300 as well. Match that first column there for us, okay? Observed minus expected. We're going to take the observed, subtract it from the expected. 75 minus 100, negative 25. 200 minus 100 is 100. And then 25 minus 100 is going to be negative 75. Again, this column should add up to 0. It does. Very nice. Now we're going to square these numbers. Let's get our handy dandy calculator for this one. All right. So 25 squared, 25 times 25 is going to give us 625. All right. 100 squared, 100 times 100 is going to give us 10,000. And then lastly, we have 75 times 75. That's going to give us a nice 5,625. Again, don't have to worry about adding those up. Last one, we're going to take this number that we got, and we're going to divide it by the expected. Each of the expected are 100, so that's very nice. I can just move the decimal place 2 to the left. So 625 minus 100 is going to give me 6.25. 10,000 divided by 100 is going to give me 100. Very nice. And then 5,625 divided by 100 is going to give me 56.25. Okay. All right, so I got all these numbers. Let's add these up. It's 6.25 plus 100 plus 56.25 is going to give me 162.5. 162.5. That's my chi-squared value. Chi-squared value is going to be 162.5. Folks, anytime you see a really high chi-squared value, probably not good. Something's probably wrong, okay? Let's keep going though, just make sure. We know that we have 3 options here. And so I'm going to say 3 minus 1 is going to give me my degrees of freedom. Should be a 2. So we're going to be dealing with this guy. I went on and got rid of the 0.01 column for you. You don't need to worry about it. Again, you're always going to use 0.05 for me and AP unless you're told otherwise. Always use 0.05. We want to be at least 95% confident that we are correct whenever we say this, okay? All right, so we know that we're 0.05, 2 degrees of freedom. That critical value number is 5.99 for my critical value. Okay. Now this is a no-brainer. 162.5 is way greater than 5.99. Let's check and see which one that is. That is the chi-squared value over critical number value. So we are going to reject the null hypothesis. We know that Mr. Click is indeed cheating in this scenario, and he should be disqualified. I hope this helped you with your chi-squared values. As always, you can reach out. Let me know if you need any help. I'd be tickled to help you out with this. Enjoy your days at home and stay safe.